Okay, so here we are in number 18, and we're saying find the measure of each interior angle for a regular 15-sided polygon. So the formula is n minus 2 times 180 over n. That's the angle, the interior angle in a regular, perfect polygon. So now we plug in the 15 for n there and for n there. So you want to have that formula on your 3x5 card. 15 minus 2 times 180 over 15. So use your calculator and you'll get 156 degrees. There we go. Now number 19 is the same kind of thing. How many sides here? 1, 2, 3, 4, 5, 6, 7, 8 sides. So we're going to use the same formula, n minus 2 times 180 over n. We're going to plug in n is 8 because that's the number of sides. So we'll get 8 minus 2 times 180 over 8. Work that out in your calculator and you'll get 135 degrees. Okay, now what's 135 degrees? Every interior angle. So like this is 135, this is 135, this angle, this angle, this angle, etc. This angle and this angle are the two we really care about. They're both 135 also. Okay, great. So what? Well, that helps us focus in on that little triangle because here, if I could, this little part right here, that has to be 180 minus 35, which leaves 45. This one, the same thing. This one's also 45 degrees, isn't it? Both those two have to be 45 degrees. Why? Because one side of a straight line makes 180, right? This is a straight line, and this is a straight line. So one side of a straight line makes 180. Okay, great. So now we have this little triangle, and we know that this one is 45, and this one is 45. So how can we find this last angle? Well, 180 in a triangle. So 180 minus 45 equals 90 degrees. Angle 1 there must be 90 degrees. There we go. All right, so number 20. So they want us to look at these and say which ones are the correct lines of symmetry. You know, like fold lines. You can tell this one right here. That goes right through the middle, doesn't it? If you folded that triangle about that dotted line, it would fold right unto itself. So that's a line of symmetry. How about over here? Is this a fold line? If you folded the triangle in half across that line, would it fold right unto itself? No. That sideways one and this one also, those two are not really fold lines. Only the one right down the middle is really a fold line. So this is our answer, and there's one line of symmetry. This is not the answer. This says there's no lines of symmetry. That's not true either. There is one line of symmetry, like answer A says, right down the middle. All right, how about the next part down here for this shape? Well, are there no lines of symmetry? Or is this let's just try the lines. Is that a line of symmetry? No. If you folded the triangle over that line, it wouldn't come unto itself. How about, well, that has the same line. That's still, or it has this line. Those are all no, those are not lines. So it must be no lines of symmetry. There's no lines that you can fold that triangle across so it'll come unto itself. So a line of symmetry is a fold line. Like this one is here, so that you fold it on that line, the shape will come right unto itself. It'll touch right unto itself. It's the same on the two sides of that fold line, that line of symmetry. Symmetry means same. All right, now we're going to give some names of some shapes on 21 here. What's the name of this shape? This is a truncated cube. It's a big cube. It's got a little chunk truncated out of it there. Makes sense on that? It's not a pyramid. It's not a prism, right? It's got that weird chunk right here taken out of it. How about number 22 down here? Name the polyhedron that can be constructed from that. What polyhedron is that? Well, if you folded up this, and this, and so they met in the center, can you picture it? They would meet like this, wouldn't they? It would make a pyramid. It's technically a right. Well, here we'll go to this next one. It's the right square pyramid. Why square? Because the base is a square. So pyramids are named by their base. The base is a square. It's a right square pyramid, and again, it would look like that, wouldn't it, if you folded those four pieces up? All right, and the right means it comes straight up the middle. It's not leaning, in other words. All right, number 23. How many edges does a pentagonal prism have? How many edges does a pentagonal prism? Well, it might help to draw one. It might help if you had right on your 3x5 card a picture of some of these shapes anyway. So a pentagonal prism, what does that mean? Well, that pentagon is 5 sides, right? So let's draw a shape. Whoops, that's not a very good one. Well, mine always end up sort of looking there, that's about the best I can do. So pentagon there, and pentagon there. That's not very good drawing, sorry. So how many sides, they're saying how many sides? How many sides? Well, we're going to connect these now. So do you see that? That's a prism. Remember a prism. Remember what a prism has? A prism has same two shapes, top and bottom, or right and left, whatever, same thing. Has same two shapes. So see how it has a pentagon? This is a pentagon, and that's a pentagon, and then they're connected by straight sides like that. That's a prism. That's a pentagonal prism. So how many sides does the pentagonal? Oh no, I'm sorry. How many edges? How many edges does the pentagonal prism have? Well, there's 5 edges here. 1, 2, 3, 4, 5. There's 5 edges here. 1, 2, 3, 4, 5. And then there's 5 edges connecting the left and the right for a total of 15 edges. Does that make sense? So you can have a drawing of a prism on your 3x5 card. That might be helpful. Take one out of a book, photocopy it. That would be fine. How about this next one, number 24? What's the name of that three-dimensional figure? I don't know if you remember. That's one of the 5 special regular. There's 5 regular polyhedra, meaning that are made, they're regular. Remember what regular means? It means perfect. They're made out of the same shape, perfect shape, all the way around. So this one's made out of perfect equilateral triangles all the way around. So you might just look around the room during the exam. We have some of those up maybe, or you can just have pictures of the 5 regular polyhedra on your card. We had those in the lecture notes. Which one is that? That's the octahedron, because it's got 8 sides altogether. Can you see there's 4 on the top, 4 on the bottom, 8 sides, octahedron. What's the name of this? Well, do you see that this thing down here is a prism? Why? Because it has the same shape top and bottom, connected by straight sides. And what kind of prism? Well, how many sides on the top? 1, 2, 3, 4, 5, 6. So that's a hexagonal prism. Hexagonal prism. Because the top and bottom are hexagons, and it's a prism. So prism has top and bottom the same. A pyramid comes to a point, has one base and comes to a point. Pyramid does. So this here would be 2, 3, 4, 5, 6. Here would be a hexagonal. This is a hexagonal pyramid. See the difference? All right. 20. So, well, there we go. How many sides on the bottom there? 1, 2, 3, 4, 5 on the bottom. So what is it? It's a 5 on the bottom. Pentagonal pyramid. Pentagonal pyramid. Hey, that answer's not there. It's none of these. And I want to give you a heads up. Some of the answers on the actual exam will be none of these maybe as well. It's always a possibility. And then last, number 27. If a polyhedron has 12 vertices and 8 faces, how many edges will it have? Well, we had a formula. Vertices plus faces minus edges equals 2. That's a true formula for any polyhedron, so it's a good thing to put on your 3x5 card. So they're telling us vertices 12 plus faces 8 minus edges is 2, so that's 20 minus edges is 2. What does edges have to be to make that true? 18, right? 20 minus 18 will be 2. 18. There's got to be 18 edges. There we go.